we identify some component or engineering practice that can lead to emission, we fix that.
Right.
Right?
It's great.
So this is a solvable problem in terms of the methane emission. He did express misunderstanding that he indicated he thought it was possible that we were sampling, abandoned coal mines or something, and that is most certainly not the case. We all of our emissions were reported for pads. We observed the plumes coming from well pad. We did observe a very large emission from a coal mine, and we reported that because it's relevant to the story of what might account for the observations of large emissions from well pads that are in the drilling phase. But it's not correct that it could have been direct emission. What we measured was direct emission from a mining operation or a defunct mine. That's not correct.
And that's spelled out in the paper, the reasoning for why you can exclude that possibility?
Well, we described how we identified the emission plumes to a specific pad, that we followed those plumes back to the pads and then we circled them and we presented an example. We didn't show every single one because, typically the intent in a paper that has a finite length is that you
Sure.
show enough examples to help the reader understand the methodology.
What that implies, presuming he would agree with that on the second look, is the key lesson you're pointing, the key revelation is that if you're drilling for gas in an area with coal mines, some particular care or issues, some particular care is required, or issues are have to be confronted related to when you go through those layers. Is that sort of the...
Sure, or we could be wrong about what is happening, but it is clearly happening in the drilling phase, and so the monitoring that he suggests could be done in areas like the Marcellus that where you are drilling through coal seams, that continuous monitoring occurs in that process in order to understand and improve the inventories.
Could you repeat what you see as the prime lesson for the EPA and or those of us who pay the taxes that apportion resources for this kind of thing?
Someone expressed concern about EPA and why are they doing a bad job, and to me that's 180 degrees away from what the message should be. It should be, really, EPA needs more resources. We want them to do a good job, and it's hard. And so there should be recognition and forgiveness when we find that there's a difference between the inventory and some apparent reality.
A lot of the reporting on it, a lot of the interest in this whole question relates to climate. And as you were saying a minute ago, one of the points that he made and what he contributed to .earth was the drilling phase is transient, and even if there are high leak rates, as the drill penetrates coal-bearing strata, they're likely to persist for a matter of days. And then he goes on to make his conclusion that, in the long run, this portion of the well development is not that relevant to the climate question in terms of how much, in a gross sense, some particular well is contributing methane to the atmosphere. Is that a fair point of his?
Well, one of the things we're trying to do is develop inventories that allow us to calculate on a large scale how much methane is going to be inadvertently spilled in this process. However, I would point out that what the scientific community here is doing, and our paper is an example, is trying to be helpful to everyone.
Sure.
Right, if there are some engineering practices that lead to loss of product, in principle, people would like to know about that. EPA and the public would like to know what the climate impacts are. And so if we identify some component or engineering practice that can lead to emission, we fix that.
Right.
Right?
It's great.
So this is a solvable problem in terms of the methane emission. So in the long run, the climate impact of shale gas operations is going to depend on how it's developed in the larger context. In other words, how much fossil fuel are we going to burn? And natural gas is one of those fossil fuels. So if the proportion of our energy needs that are met by fossil fuels is a constant, but we divert some of that from coal to natural gas. In principle, that has a climate benefit, and it has a very big human health benefit because there are no sulfur emissions associated with natural gas. And tens of thousands of people die each year from respiratory problems related to ozone and particulate matter, some of which is from coal combustion. So that's an important point. But if we expand our reliance on fossil fuels because of the availability of natural gas, then the climate equation is more complex.
That's sure.
That if we expand this natural resource and end up emitting more CO2 than we would have otherwise, then it's not, the question is not just about what is the carbon intensity of the fuel. So natural gas emits less carbon per unit of energy that is produced. So it's a lower carbon intensity fuel. But if we end up, because it's available and relatively easy to produce, if we end up expanding our reliance on this source, then we might run the risk in the long term of losing some of that climate benefit. So I agree with that comment that CO2 matters. It's not just about methane, because with studies like ours, we'll find leaks and we'll plug them.
It's really valuable work. And I've written about this at the local level, even just using an infrared camera. I did a piece back in 2009 where the EPA had done some rough cut work with just infrared photography showing all kinds of gas infrastructure leaking, large amounts of gas that you would never notice if you were looking with visible light. And it just seems so glaringly obvious to me that if you can convey that reality more visibly or with data, obviously, it's a real great guide to us on how to tighten things up.
Yeah. I mean, this is a relatively solvable problem. And I'm sure that we will do that. We'll do, the industry will do a steadily better job.